How can we make it easier to build robots? Good developer tooling is a great start, and one of the biggest parts of tooling in my mind is visualization. In this interview, I talk with Adrian Macneil, who is a co-founder and the CEO of Foxglove. If you're a robotics developer, you probably know them and use their visualizer. If not, you probably want to check it out. What you may not know is Foxglove has a whole data infrastructure from recording data to getting it off the robot and selecting which data you want in the cloud. And of course, their specialty, visualizing it, which works for live data and recorded data. In this interview, we talk about all the parts of Foxglove and how they fit together, opportunities for startups to build robot tooling, Foxglove's 2.0 release and their decision to move away from open sourcing their visualizer, and Foxglove's upcoming one-day conference, Actuate. Actuate looks like a blast. Its goal is to have conversations where robotics companies can share their learnings, kind of like what's done at academic conferences, but with more of an industry focus. If you do decide to go, you can use the code Audrow, AUDROW, to get 20% off. It's not a referral. I don't get anything if you sign up, but I'm flattered to have a promo code. Anyway, I hope to see you there. With that, here's the interview. Hey, Adrian, would you introduce yourself?
Hi, Audrow. My name is Adrian Macneil. I'm the co-founder and CEO at Foxglove.
Awesome. Would you tell me about Foxglove and kind of how it came to be?
Yeah, absolutely. So Foxglove we think of as a visualization and observability platform for robotics. We've been around for about 3 years now as a company. Prior to Foxglove, I spent 5 years working in the self-driving industry at Cruise in San Francisco. Worked on a lot of the internal infrastructure, internal tools, developer tooling, simulation infrastructure, a lot of those pieces at Cruise. And really came out of Cruise feeling like there was this enormous, I guess, number one, there was this enormous opportunity for automation and autonomy and robotics in the world, seeing if we can put a car on the streets of San Francisco. You know, how many other sort of tasks are done by humans today that are dangerous, repetitive, difficult, that are honestly much easier than driving around San Francisco. Like if we have self-driving cars, how come we don't have sort of self-driving tractors in an empty field or self-driving forklifts in a factory yet? So I came out with this sort of huge excitement about what was possible with autonomy, but at the same time, really feeling that the industry was being held back by a lack of tools and infrastructure and frameworks, having seen kind of everything we had to build from scratch at Cruise. So that was kind of the genesis of Foxglove, was how can we push forward the robotics industry? How can we build tools and infrastructure that really accelerate the industry? And we started with this piece around visualization. We started with the Foxglove visualizer, putting that out there, making it easy for folks to bring in different types of data, for example, from ROS. Or very quickly, early on, we sort of started adding support for other frameworks and other data formats like protobuf and things, and letting people bring this multimodal data into kind of a visualization framework. That was really where we started. And this is a problem that's pretty unique to sort of robotics and a lot of these kind of ML workflows. If you think back to traditional observability, you think about tools like Datadog or Grafana. They're really built around time series data, metrics, lots of plots, but no ability to show you 3D data, no ability to show maps, no ability to show point clouds or anything like that. So we started with the visualizer, and then over time we've sort of expanded into this broader, what we think of observability as everything from how you're logging on a robot, how you're offloading data from robots, how you get it to the cloud, how you store and index it, and then how you can visualize and analyze that data.
Mm-hmm. Yeah, so you're carving out a very nice vertical with this around all things data related.
Basically, yeah. We see sort of the whole data lifecycle of from your recording on the robot, because these are things that are they work quite differently from a traditional infrastructure space, right? Like I came to Cruise, I want to say 9 years ago or something at this point. From an infrastructure background, not from a robotics background. And I saw how much robotics engineers struggled with a lot of these things. But the traditional tools that had built up around sort of web servers and the web over the past couple decades did not immediately apply to robotics. So you think about some of these things like what types of data are being logged. I mentioned, right? With
Mm-hmm.
websites, you're usually the logs coming out of like a web server is typically sort of text logs. So like that's pretty lightweight in terms of data. You're generating a lot of text logs, and then you're generating maybe some time series metrics, things like your server response speed and memory use and CPU on the server and things like that. But it's like pretty lightweight telemetry in the scheme of things.
Mm-hmm.
And then this is deployed in a server room. So you've got this, we're deployed in a data center. We've got like effectively infinite bandwidth, and we've got like very lightweight kind of telemetry coming off web servers. And then you go to robotics, and it's the complete opposite on both of those, right? You've got instead of like very lightweight telemetry, you've got incredibly dense data, sensor data. You've got video, you've got point clouds, you've got all of this kind of data. It's very multimodal. It's very heavyweight quite often, and then almost universally terrible internet, or some like pretty.
Yeah.
It's not a data center. Let's put it that way. There's you're in a factory. You've got Wi-Fi. You've got shitty Wi-Fi. You've got or even if it's a fixed position robot and it's connected with Ethernet, it's still in a factory. There's still maybe like you're lucky if you've got a 100 megabit uplink or something. Or we're deployed into a field where you've got maybe like some spotty 3G service. You're getting into maybe Starlink if you're lucky, but you're not going to be streaming sort of, multiple HD video feeds over that. So you kind of invert on both of these spectrums. Because of that, you can't just go and reach for an existing off-the-shelf observability tool. Something like Datadog is just completely sort of non-applicable to the robotics space. And so, yeah, we see this as something where robotics is, the needs of robotics engineers and robotics companies is unique. And as a specialized tool for this is important.
Mm-hmm. Now, I would love to go into each of the parts of the system, because you mentioned, so you have the visualization, logging, transport. Like, tell me about these.
Yeah, absolutely. So, kind of walking through an order of how we sort of see the data journey, the data lifecycle on a robot. Recording is one of the first ones that we think about, right? So one of our open source projects at Foxglove is called MCAP. MCAP is a standardized kind of recording and logging format. If you think about recording in a robotics context, probably the sort of thing that a lot of people would be familiar with is ROS bags. And the ROS bag sort of file format was designed along with ROS1, probably 15 years ago or more at this point. But it was one of the first formats that sort of natively supports recording multimodal streams of data into a single file. And we think that this is a very important property, being able to take all of these different streams of sensor data, putting it into a single file. The alternative, and we've seen this at companies that sort of created pre-MCAP or didn't use ROS early on, the alternative typically ends up being sort of a junk drawer approach to logging, right? So there's just a folder on the robot. There's some CSV, one piece of the stack is logging some CSV data, one piece of the stack's logging an MP4 file, one piece of the stack is dumping some random binary data to disk, and then there's some YAML files thrown in for good measure. So this is kind of the junk drawer approach to logging. They're like, great, now we get these logs off the robot. It's just like a folder full of crap. We zip it up and like, who knows, how you go and kind of interact with that later. But we think that this nice property that ROS bags kind of originally created is like everything should go through a single format, even if it's completely different types of data, even if it's some of it's sort of structured data, some of it's unstructured, some of it's, multimodal video, point clouds, some of it's time series. You want to put this all through a single log format, make sure everything is time-stamped, consistent. That was a great property of ROS bags. But we saw, the robotics ecosystem is broader than ROS. We saw a lot of companies struggling with where they were not using a ROS stack, and therefore some of them sort of weirdly converted data to ROS just for logging. Some of them did the junk drawer approach.
That's hilarious.
Quite a few companies we spoke to had just invented their own sort of bespoke binary logging format. So we've created something internally. We just dump this binary data to disk. Good luck interacting with any other services, or good luck even reading your own files from a year ago, because who knows sort of how the format evolves. There's no kind of spec to it. So this was a problem that we set out to solve quite early on, back in 2021 with Foxglove. We saw this as a key sort of problem in the industry, that there were no open standards outside of ROSBag that people were using for logging. Created the MCAP project. That actually got accepted. I think maybe a year ago or a year and a half ago, it got accepted as the default logging format in ROS 2, which is great. We're seeing a lot of adoption of MCAP within the ROS community, but also a lot of adoption of MCAP outside of ROS 2. There's a number of some of them I think on the MCAP website logos that you'll see of big companies. I don't want to name ones that I'm not allowed to, so I'll just have a look at what's actually listed publicly on the website. We've got there's some ones here like Audrow, Dexterity, Coco, Apex AI, Tangram, Wabi. So there's a few of these, really large companies, both within and outside of the robotics ecosystem that have adopted MCAP. So that's how we think about the logging piece, right? And because the logging piece is on your robot, that needs to be open source. That needs to be a completely open standard, open framework. MCAP has libraries in about 6 different languages. There's C++ and Python and Rust and JavaScript and Go and anything that people are sort of using on their robots.
How does it work? So how would you describe, at a high level, how does MCAP work and how does it unify things and why is it better than ROS-BAG?
Yeah. You can think of MCAP as a successor to ROS-1 bags. So ROS-1 bags was a file format where it can take basically all of the channels of ROS data and save them into a single file format. Every message that goes in is timestamped. There's an index at the end of the file in the ROS bag that sort of helps you if you need to seek around and things within the file. But there was a few sort of challenges. The ROS-1 bag format was not bad. A few challenges that people had with it. One is that it was tied to the ROS ecosystem. Not just, in 2 ways. One is that you could only log ROS data to it. So if you had other data, you've got some protobuf data or some just other sort of generic data you wanted to save, you were back to the junk drawer approach. Now you've got to save that separately. Another way it was tied to the ROS ecosystem is that the ROS, whatever it's called, ROS bag pile or whatever, the libraries to interact with it are also only available through the ROS repos. You can't just like pip install a general purpose package that would let you interact with it. And so this becomes a problem in ML, like further on in your robotics development. You've got ML pipelines, you've got ETL pipelines, you want to do like post-processing on the data. You don't necessarily want to install like all of ROS or set up the ROS repos or any of this kind of stuff. You've just got a standard sort of, Python app that you've written and you want to just pip install something to interact with it. That was not possible in the past with the ROS bags. So you had, a couple of these challenges. And then in the early days of ROS 2, there was a switch to a SQLite-based logging format, which it's unclear that sort of some of the design decisions and people behind the history of sort of how that decision came to be has been lost, I think, to the to the sands of time. It appears to be a decision that was made in the early days of ROS, but and I think the intent behind the SQLite logging format was to bring it kind of, as I mentioned, ROS bags was hard to interact with outside of the ROS environment. The intent was like, hey, let's use an existing open standard SQLite. There's plenty of readers out there that would let you unpack that. Unfortunately, sort of the downside of that is that SQLite is a relational database, so it's not designed for high performance stream sort of append-only logging or anything like this. It's not, in terms of how you think about inserting a row into a SQL database, it's hyper-optimized for sort of jumping around and sort of inserting rows arbitrarily and updating indexes and all of these things that are not at all necessary when you've got a stream of log data that you just want to flush to disk as fast as possible. So people were seeing a lot of problems with that. Notably, it would basically just drop a lot of messages if it ran out of CPU, or the CPU was being too taxed. It would just start dropping messages, and then they would not make it to your log file. So there were some challenges being faced there. And then with MCAP, the design of the MCAP file format is quite similar to a ROS-1 bag. The other analogy I would say with an MCAP file is it's similar to an MP4 file. So an MP4 file, people think of as a video file, but it's not actually. An MP4 is just a container. You can put anything inside it, and inside the MP4 file, you're putting streams of typically something like H.264 encoded video, plus some AAC encoded audio or MP3 encoded audio or any of these kind of things, right? So it's a container. MP4 is a container format, just like Matroska is also a container format, MKV. These are containers, and then inside them you have channels of audio and video. MCAP is kind of similar to that, except inside it you can have channels of anything. You can have channels of ROS messages. You can have channels of CDR messages from ROS2 and DDS. You can have channels of protobufs. You can have channels of flat buffers. You can have channels of JSON, whatever you like. So think about it as just a container format. Everything that goes in the container is time-stamped so that it fits into the sort of stream that you're writing. And yeah, then you can go and kind of unpack that later. And like I said, the libraries are available kind of independent from the ROS ecosystem. Even if you're using it within ROS, that's kind of a nice property.
Yeah. Okay. That sounds really nice. So you have this container where you can store all these different channels. You can pull them out really nice. And then you also have different language support that doesn't require you to use or install ROS on the ecosystem, use Ubuntu or Windows or whatever it's supporting, but it's a heavy dependency. And so that's very nice. And that probably makes it a lot nicer for, as you were saying, like ML pipelines, people who are doing data analysis. They don't need to maintain a working ROS distribution on their system.
Right. Yeah, I mean, even within Foxglove platform, some of our backend services that ingest MCAP files or stream MCAP files are written in Go, for example, right? And they have no dependency on ROS. We're not running on Ubuntu 2004 or outdated version of Ubuntu tied to like a specific ROS distribution or anything. It's just, hey, we've installed the MCAP Go package, and that has the has everything you need to interact with it. So you have this sort of like level of independence that I think is kind of
very
healthy.
Desirable.
And then of course you still have the tight ROS integration for people that are using ROS.
Definitely.
Yeah.
Okay. And so that's the recording part. So you're putting it in a format that you can use. So MCAP, does it refer to anything, or is it an acronym?
It's unofficially it's message capture, which is sort of a play on PCAP, which is packet capture.
Nice.
We don't sort of expand that anywhere. We call it MCAP, and it's
a catchy name.
Yeah. We went through we had a sort of internal voting on about 50 different names, I think, but MCAP. MCAP. Okay. I don't even remember what the other suggestions were. This was 3 years ago now, but
how funny.
But yeah, there was I think MCAP kind of stuck out as being philosophically similar to PCAP files, which are a network file format that allows you to capture all of the packets going out on your sort of IP address. Nice. through your TCP IP stack. You can capture all of these, all of the packets going forth, and then you can go and inspect that later. We're sort of thinking this is a higher abstraction, right? It's not at the level of individual packets. It's at the level of messages, ROS messages, or other messages in a pub sub system.
Nice. Yeah. I like that. And it also makes sense because maybe people familiar with PCAP can map over their understanding, and it's a different abstraction.
Yeah. It's
Okay.
I mean, it's sort of conceptually similar, although mostly it's just a catchy name. And then at some point, one of the team members threw in the hat logo sort of caught on, and that was sort of a little bit of a dad joke that made it in with.
That's great.
Yeah.
Hell yeah. Okay, so we have MCAP for recording. Where do we go from there? Moving up the stack.
Got to get the data off the robots. So this is sort of how we think about as upload and ingestion. As I said, within the robotics space, usually you are logging very, very dense data, and then you've almost universally got a pretty limited internet connection. Bandwidth constraint is just a universal problem in robotics. So how do we get the data off the robot? During early R&D, this is not as, it's not really as much of a problem people run into. They're logging on the robot. Probably the robot's right in front of them. They, hook up an Ethernet to the robot and SSH and copy some files off. Or, they just plug in a portable hard drive to the robot and, off they go. As you start getting to robots in the field, you start getting the robots are not deployed where your engineers are, where your team is. So you want to start debugging data. You're not going to have like your entire engineering team on site at wherever the actual robots are being deployed, even the first few. And certainly once you get to scale of thousands or tens of thousands of robots, you're going to have them deployed sort of all across the country, all across the world. And you're going to have your engineering team is going to, possibly be in one place or possibly be distributed, but probably not where your robots are. So how do we get the data off? First of all, it sort of depends what data you want to get off. We see a lot of people eventually move to some kind of rolling record type setup. So this, might involve having a day or maybe max couple days worth of data logged on the robot. You've got enough storage space on there for 24 hours of log data, say, but you're just overriding it unless something goes wrong, unless there's something notable.
It's like a home security system or something.
Yeah, exactly.
Where it just keeps overriding itself.
Right. It's like if someone breaks into your house, you got to go quickly sort of pull the tapes out before. Yeah, or like a black box recorder in an aircraft or something like that. So but you do want to capture the data if it's, for example, something went wrong. Obviously, like robot, crashed into some like packaged goods or fell down the stairs or whatever the robot was kind of doing wrong. Those are obvious ones. The other areas that you might want to capture data are things going well. You want to just capture a distribution of data for your ML training, things like that. You want to sort of get a nice distribution of different events. But we usually see people moving towards some kind of rolling record type setup. The exception to that would be companies that are operating in public, so self-driving cars, but also things like sidewalk delivery robots and things like this. There is usually a higher there's usually a desire with those types of robots to save it for more than just what you could fit locally, probably more than a day, right? You want to be keeping most of the data around for like a month or a few months or something like this, in case someone calls up and says, hey, you cut me off on my bicycle, I'm suing you, or something like this. You want to not say, oops, it may be weeks later that you find out about a potential incident.
And so we usually also they generate like autonomous cars at least generate so much data. So I imagine they need to offload it because they can't store it because it's just incredible amounts.
Exactly. Yeah. So in the AV industry, and it's a maturity curve, right? You get to the point that sort of like a Waymo is at today, and you're absolutely going to see a rolling record and not saving everything that's happening. But until you reach that level of confidence, for all of the early years, it's usually something that looks like logging to sort of hot swap hard drives on the car, and then when the car's coming back to charge or to fill up or be cleaned or whatever, serviced, we're just popping those hard drives out and switching them out for fresh ones. From there, of course, you've still got this just ridiculous quantity of data because a self-driving car can be logging multiple terabytes an hour easily. So you got to get all of that data off a car and up to the cloud. That requires a pretty extreme internet internet connection. But yeah, that's sort of the AV use case is a little bit unique in that world, in that one where it's like you're operating in public, and you're a lot more sensitive to things that potentially might have gone wrong that you might not find out about. You don't see that as much in sort of like a warehouse AMR or something like that. Usually the amount of damage that an AMR can do driving at 3 miles an hour in a warehouse is fairly limited. And also a lot of the time, a lot of these warehouse AMRs have a lot of people around. They have buttons on them where you can report sort of incidents and things like this. So you might be perfectly happy just saving a couple minutes, maybe a minute or 2 minutes of data every time there's something notable, and then just throwing the rest away.
Okay, so back to this data upload problem. Yeah. So what do you guys have in place? So I guess there has been this, what people have done is they often record the data in place but I guess if you want it for machine learning, and so you want to train on that data, you want to get that data off. Connectivity is very bad, or not very bad generally, but limited, often can be very bad. So how are you guys solving this, or like what's your approach to getting data off the robot and storing it somewhere else? Yeah,
exactly. And so we offer, and I think there's a lot more to build out here over time, but we offer a agent that we call the robot agent. You can drop it on a robot, and it'll watch a directory of log files, of MCAP files or bag files. So let's say you're running a ROS robot or a ROS-like robot. It's recording a lot of data to MCAP files, to ROS bags. Those are the files typically get rotated every sort of 60 seconds to a few minutes. Quite often people are splitting the files up every few minutes just to to kind of make them easier to work with. We have an agent that'll sit there and just kind of watch that directory, keep an eye on new files that are coming in, and it notifies the server in the cloud about what files are available. And then, so we have an understanding that, hey, you've got this fleet of robots out there. They have these, this data is available for import from the edge. And then you can sort of trigger an upload in one of two ways. You can either do it from the robot, so you can send a message to the robot agent and say, hey, flag this particular file, or say, can you queue that for upload? Or you can do it as kind of a pull-based mechanism from the server, from the cloud. So I can go to the web portal, I can click on that robot, I can see the timeline of data that's available. I can't view it yet. I know that there's data there, but I don't know what that data is. But I might, the pull-based workflow, the push-based where the robot initiates it is great when the robot identifies something wrong, because the robot identifies that there's been a collision, or the robot identifies some other kind of error that it wants to report. It can trigger an upload. The pull-based workflow where the user is going to the cloud and requesting it is good when they get a call from the operations team saying, hey, at 2 p.m. this afternoon, there was this incident with the robot. Can you guys take a look at it? You might want to go in and fetch, just kind of grab 10 minutes of data around about when some problem was claimed to happen, and then sort of offload that, pull it from the robot, and have that sent to the cloud so that you can then go investigate.
Okay, so it's not towards like dashboards or anything per se.
No,
like
we haven't.
Streaming.
Exactly. We've stayed away from that. There are a lot of tools that do that already.
Yeah.
So you've got, Foment is probably one of the most known ones, but but there's a lot of these tools that are creating sort of more of a live overview. I call it like a fleet management platform. We don't do anything in the fleet management space. It's sort of a little bit. It's a different problem category, I think, to what we're solving, right? Like, we're focusing on the needs of robotics engineers, robotics developers, and getting sort of what is usually sort of async access to raw, detailed logs about incidents, versus kind of a fleet overview, which is sort of more of like an operations workflow of just like, hey, I want to see where my robots are. I want to click on this one and send this one home. I want to see how many, tasks per hour are being completed by different robots. So, this kind of stuff is, it's a different kind of product category and problem space. It's adjacent to what we're doing, but it's not something that we have focused on now, and we're unlikely to be focusing on in the near future.
Okay. So that sounds cool. So you have something that you have your agent. Your agent is watching a folder, and it's letting you know when there's something there, and you can pull it from whatever computer you're on when you're not close to the robot, or it will push it, or it can push it periodically. And it's really just, you're going to upload the whole thing when it's pushed or pulled to wherever it is that it should be sent to.
Yeah, and snippets of data. There's different ways to configure this. Sometimes
you can grab
another pattern that we see sometimes is people will actually log two separate sets of MCAP files on their robot. They'll be logging one that's kind of all of the lightweight telemetry on the robot. So things like just kind of the robot pose, maybe GPS position, sort of system state, just stuff that's like very lightweight. And then a separate file that's logging all of the heavyweight sensor data, the video, the point clouds, anything like this. The beauty of that setup is that you can actually just always upload the lightweight stuff. So you always get some amount of detail. Not immediately, because it's still kind of an async batch upload workflow, but at some point within maybe 10 minutes of real time, 5 to 10 minutes, you're seeing enough data that you can sort of figure out where a robot was at any point in time. That might help you narrow down on, say again, someone calls you up and says there was a problem at sort of 2 p.m. That will help you narrow down on exactly when that problem was and roughly where the robot was. Then you can sort of select a time range and go and fetch the more sort of detailed HD logs. So that's quite a nice pattern that we see.
That is a really cool one.
Yeah. Okay. But you do all of that, and then your data gets to the cloud, right? And again, all of these, one of the philosophies of how we build Foxglove is trying to make this really modular, because not everyone wants all of these pieces, right? Some people have already figured out their logging. Some people have already figured out their upload workflows. They don't need help with that. But others haven't. We just kind of say, well, pick and choose the components that make sense for you.
Yeah. So you support the full vertical of like I record my data to I do an analysis on my data, but or whatever it might be. I use it for training.
Right.
But you can use it for only specific parts. So if you just
Right.
want to
Yeah.
upload the data, or if you just want to visualize the data,
Yeah.
or you just
Yeah.
this
Yeah.
kind of thing.
Yeah. I mean, if you just care about sort of uploading and organizing your data in the cloud, that's a thing you can do. Typically, we find you get to the sort of last part we'll get to around visualization analysis. Usually, those workflows are pretty sort of common across everyone. But yeah, absolutely, a lot of people have come to us and initially wanted to focus on sort of the data workflows, and then they get into the visualization. Sometimes it's like start with the visualization. I'm happy with how I get data off the robot. I just want to visualize it. Great, that's fine. We can kind of start at that end. But yeah, as we're getting all of this, we're triggering these uploads, we're getting logs coming off the robot. Then you get to the data in the cloud, and again, sort of we see a lot of robotics companies, at least pre-Foxglove, was just, well, there's an S3 bucket. We've got an Amazon S3 bucket. We dumped a bunch of bag files in it or something like that. So if you know what file, you know the file name you're looking for, great. But if you don't, kind of good luck to you. So that was sort of the problem we set out to solve with the cloud indexing was, okay, as these files are coming in, let's do an ingestion step where we look at metadata on the file. We look at what time range is being covered by this file. We look like what robot it came off. What topics are inside the file. So we go through this ingestion step, and we store all of that in a nicely organized, indexed bucket. Either we can, either Foxglove hosted, or it can be hosted in your own VPC with any cloud provider. But we sort of go through this ingestion step. We organize it into a nice sort of folder structure within your bucket, and then we also give you a web UI so that you can search across it. Right? You can just go in and type in and search metadata. You can look at a timeline view. You can kind of do a few more of these things to get a more sort of like visual overview. If you want to look up sort of you know which robot you're looking for, and you know the time range, or you don't know the name of the file, it's much easier to find the sort of particular logs that you're looking for.
Yeah. I feel like this is something that's so simple and so valuable for companies to use.
And everyone has, I mean, and I don't claim a lot of the stuff that we do, right, is not rocket science. It's just really undifferentiated, because you see every company build a web UI for looking at Ross bags or something like this, right? And you're like, this is just silly. Everyone shouldn't need to build this.
Yeah, for sure.
Yeah.
And then a UI for filtering through the data.
Right. Right.
Yeah, I'm seeing a lot of analog to like home security systems with this, because you can look for this camera at this time, at this whatever. You look for this robot from this time window, and you might be able to filter by a specific event or something that occurred.
Yeah.
So you're pulling out metadata by processing what has been uploaded. You get the start time, end time. Maybe you key or tag it with things like this is this robot in this warehouse and this whatever.
Exactly. Yeah, you can tag all of that metadata, assign it to what we call a device, which is your robot, and then you're able to sort of view all of that data on a timeline, or you'll be able to pull up just the logs for a particular for a particular robot, or if you are tagging them with metadata such as which factory or which site it was operating at, tag it by that kind of metadata as well. But you've got this kind of quick search across all of the data.
I like it. Okay, I think that's really nice. And that feels like something where companies might plot along in their like terrible naming convention, like the file name contains all the information, where it's like this is the time, this is the robot.
Yeah.
And then that is probably, it works, but it's super painful, especially as you get a lot of robots and a lot of data. And then this makes it so much easier. And then you have the UI, which is really nice for filtering and things like this. So,
And there's a lot more that we can do there too. I mean, today we let you sort of search by metadata that you've pre-added. Some of these things, like you said, by robot or by, other metadata that you add, like factory and things. But there's a lot of other ways that you could imagine exploring this data. Like, one we would like to add in the future would be a sort of a geospatial search over, can I see all of my data on a map? If you just kind of see like a heat map and then like zoom in and say, okay, well, I want to pull all of the logs, all of the times that we've been past, whether it's an indoor map or an outdoor map is sort of not, similar kind of concept, but like I want to pull all of the logs or all of the times that robots have been to this corner of the factory, or they've been through this intersection, or things like that. Those types of searches are things that we would like to add in the future to make it, really easy to pin down on the particular data that you're looking for.
Yeah. I feel like there's a lot. I mean, you could do a lot of analysis. You could do a lot of displaying stuff. Like, the ceiling's the limit for what you could do to expose different data things there. But that seems very valuable. Spatial seems super valuable.
Yeah.
Specific events could be valuable. Having them write their own event
Yeah.
detection that
Yeah,
goes
we
through
do
the
it.
data
Yeah,
and looks at this
we do
channel.
have an event. Yeah, we do an event concept, so you can kind of whether whether those are being created through the API from things that are happening on the robot, or whether it's being created, you can just go into the UI and sort of annotate your own events manually, but tagging points in time where notable things
so
happening.
tags
And
are
then,
super cool. Okay, so
Yeah.
we have this cloud indexing, so you're
Yeah.
able to get your data very effectively. Where do we go from there?
Analysis and in particular visualization. So visualization is, like I said, this is kind of where we started, the end of the problem that we started at.
Yeah. I think in our last interview, which might have been 2 years ago
Yeah,
now
it was
at
a
this
while
point,
ago. Yeah.
it was most of what you had was the visualization part, and you probably were working on the cloud part, and it was pre-MCAP too,
Right.
if I remember
Right.
correctly. So,
Interesting.
okay.
Yeah.
Yeah, time flies. But
Yeah, it
okay,
does. Yeah, there's a lot has been built in the past few years. But yeah, so we started with this visualization, and again, another difference between sort of observability with servers and sort of traditional infrastructure versus robotics. In traditional infrastructure, you think of a tool like a Datadog or Grafana or something like this. You're creating a lot of nice, pretty plots and dashboards and things, but usually only with data that's already in the cloud. So this is why the arc of data goes from like logging to get it to the cloud to indexing to visualizing it. But in robotics, visualizing cloud data is only one of I would say 3 kind of common workflows, right? So one is visualizing cloud data. Another is visualizing local files. I've just got some files that I've
not uploaded,
or SCP'd off a robot, or not uploaded, or I'm mucking around locally. Another is live visualization. So this could be either I'm connected to a robot over Wi-Fi or Ethernet, and I'm literally just like plugged into a robot, and I want to see the data coming in live, and I want to check that the calibrations are correct and the data sort of makes sense. Or another option with the live one is if you're running some kind of sort of resimulation or some kind of simulation on your just on your local workstation, your local laptop or desktop. And so you've got a robot stack running. You might not have an actual sort of full like hardware in the loop or anything. It's just running a stack locally, but you still want to be able to see the output of like what your stack thinks is happening, what your stack thinks is seeing.
So I'm thinking very similar to RViz for this one.
Right, exactly, yeah. And RViz really only supports the live visualization workflow. So when you want to visualize things with RViz, you can connect to a live running ROS. You can see that in real time. But if you want to go and replay, if you want to go and sort of explore a bag file or MCAP file, you have to go start up ROS in the background. You have to start up, run ROS bag play. So you've got like 5 different kind of terminal windows in the background with your ROS stack running and your ROS bag play running. And then if you want to kind of pause and rewind something, you've got to do that sort of in the terminal from
Totally.
Yeah, which is so there's no with something like RViz, right? You have no native support for a kind of for like a file-based or a cloud-based replay workflow. You only have this kind of live visualization.
Now, one thing with RViz is it's running on your local machine. I know Foxglove can be too, but running through Electron or however you're displaying it these days. But so RViz might be more performant, would you think? So if data's coming in really fast and you want to display, or does it not matter because it's human perception and we're going to see
it really depends.
30 or 60 hertz? How do you think about this?
It depends a lot, right? I mean, in terms of the rendering, 3D rendering and things like that, that's all running through WebGL. So a lot of the things, are actually already hardware accelerated. A lot of the code in a browser environment, people think about a browser environment. The browser has evolved a lot in the past 10 years, right? You've got companies like kind of Figma and things that are really pushing the boundaries of what's possible. You've got services like we're using now, services like Google Meet, things like this, where they're doing like live video and streaming and things in the browser. Most of that code that's running is C++ code, right? Like most of it is it's running in the background of the browser stack is implemented in C++, and you're just kind of triggering it from JavaScript. The same is true with a lot of this 3D rendering, right? So a lot of the stuff that's kind of happening in Foxglove when you're looking at a 3D view, like you would see in RViz, that is, that's running through WebGL, which is then being like in most cases hardware accelerated. Same when we do things like H.264, like video decoding and things like that. There are actually these days there are browser APIs that'll let you use hardware accelerated decoding for video and things like that. So we leverage a lot of that.
That's awesome. Yeah, it's so cool. It's like a rising tide lifts all boats. You get to benefit from the massive investments going on into the browser.
Right. Right. Yeah, and it's a great platform, right? Like the browser is very extensible. It's very easy to develop with. We can let people. It's pluggable, right? We can let people kind of create plugins and things very easily, or create little forms and things like that that they want. And then also, the other thing with others is sort of others mostly gives you the 3D panel, right? If you want to do things like plots, you're popping out to a separate like RQT or your plot juggler or things like that. You don't sort of you can't kind of just like bring it, or maps and things like this. You can't kind of bring it all into one. Yeah,
you have a bunch of windows open for sure.
Yeah. But the performance thing is not kind of a major thing that comes up. It really depends on what people's data and workflows look like, and there's such a variety within the robotics space that you just it's hard to kind of say concretely like X works better than Y without looking at the type of data that people are trying to use it with.
Very interesting. Was this the case say 2 years ago or something when we talked? Because I remember, or maybe it's just the general perception that because it's a web app, it can't have good performance. And it's surprising to me and very nice to hear that you're getting wonderful performance and it's hardware accelerated and things like this.
Yeah, it is. I mean, I will say there's like a lot of stigma out there around kind of Electron apps and things like that. But I think in some in some cases, Electron is like a victim of its own success, right? It's sort of has created a platform that is so easy to create cross-platform applications with without having to sort of go into some of these more esoteric like problems that you have on specific problems with specific platforms. There are actually some sort of other alternatives that have come out more recently. There's one called Tauri.
Tauri looks sweet.
Yeah, Tauri. So this is this is kind of a middle ground, right? It's like it's still letting you use the web stack to create an application, but it's using the OS specific built-in web view components. The nice thing about that is it reduces the file size that you're downloading. You're not having to ship a specific version of Chromium with that build. But that is also its biggest downfall, right? Because the nice thing about the way that we package and distribute Foxglove is that we can guarantee that it doesn't matter you're on Ubuntu 18 or 20 or 22 or 24 or Windows or Mac or Windows 10, Windows 11. We're not trying to guess at like what a web view, a native web view is doing. We're not dealing with the problems like Safari is actually like really behind on a lot of bleeding edge web features, for example. So we're not dealing with like, hey, this problem that only seems to happen on Mac. Very occasionally.
And that's better for you guys as developers too. You have far less maintenance burden.
Right, exactly.
Like Ross, we just as a developer on the robot operating system, it's like every time there's a problem on Windows, no one wants it.
No one's, And then also it's like, good luck if you're on a Mac, it's basically unsupported. I mean, they call it tier 3 or something.
Tier 3 now.
Yeah.
You can build from source, but we don't know kind of thing.
Right, exactly. Yeah.
But, okay.
Yeah, so this is, these are huge benefits, especially when you're a small team trying to focus on building a great product. I will say performance, issues come up from time to time and customers bring them to us, and it's usually a case of looking at just specifically what's different about their data and how can we improve that. It is a thing that we spend ongoing effort on. And, if folks do have problems, we encourage them to kind of bring them forward because it's, like I say, sometimes it's hard to know if someone has an issue, sort of like where exactly that's arising from.
Definitely. Okay,
Yeah.
so we have going back to visualizations. Okay, and it is an Electron app, which you guys are
Correct.
Foxglove
Yeah. So we built it
main
as
visualizer.
yeah, we built it as a web application. Most of our users are on desktop. Actually, I think from memory, it's sort of like a majority of people are using the desktop app more so
Hmm.
than actually using it in the browser.
Through the
But
browser.
again, the nice
So
thing
it's
about the
similar.
desktop app is you can just kind of install it and it works on any platform.
Hmm. Yeah, it's
But
super cool.
yeah. So yeah, we have that, and I guess we're saying this word visualization, which I assume to like most sort of roboticists is a sort of familiar concept, but surprisingly unfamiliar outside of robotics, right? People sort of you go to an average VC and say we make robotics visualization tools, you'll get a blank stare, right? Like this is not a product
Like, what do you
category
need
that
to
is
visualize? Yeah,
right. They're like, well, what do you mean?
I've
Who
never
would use
thought
that?
about
Why would
this.
they, get all
Yeah,
these questions like,
totally.
well,
How,
why would I
how,
use that as a robotics developer? You're like, I don't even know how to explain it. I was like,
I know. That's so funny.
in fact,
It's funny to realize how much in our bubble we are, because the idea
yeah,
that that's not clear is
right.
surprising to me too. And I suppose you talking to VCs, this is something that's really come up because they're
Oh
out of the
yeah,
bubble sometimes.
that and yeah. I mean, because I mean, every industry has its sort of its uniquenesses, but I think
Totally.
as especially as you look at kind of investors and things, a lot of the times industries are a bit more mature and they're a bit more mapped out, and they can go and see these little like logo clouds and understand how all the pieces fit in, and they sort of are like, oh, you do a thing in the XYZ category, and then you pop up in a category that that's not
There's
represented on
nothing
their
else.
little logo cloud, and you sort of have to explain from sort of first principles. But I do, I mean, I do think, and if anyone listening is not a robotics developer, visualization is something that is critical to robotics development from day one of your very first robotics hobby project to we're working on autonomous robots in space or autonomous vehicles or autonomous trucks in production, right? It's a thing that you put together your first toy robot, and then the first thing and you stick a camera on it. The first thing you're going to want to do is like, all right, well, can I see the data coming out of the camera? Can I see like where this sort of robot thinks it is in its surroundings? You're doing some like sort of SLAM, or you're doing a 2D LiDAR, or even the most basic robot, you sort of immediately run into this problem of how do I visualize kind of what the robot is seeing and thinking. And so
Yeah, how do I check where I am or where the robot
right,
thinks it is?
right,
Yeah.
and it's an inherently multimodal problem. It's not something that you can just look at text logs or sort of plots and things to understand. You need to be able to see kind of across all of this data. You need to be able to see in 3D space, sort of a model of the robot and what it thinks its surroundings are, and things like lidars and radars that are giving you sort of a sense of depth in space. And then you also want to see video data coming out of cameras. You also want to see GPS data on a map. If it's got a GPS, you want to see sort of you do have a lot of like plot data. You want to plot things like joint sort of positions or motor torque velocity, things like this. You do have text logs as well, but you have all of this, right? You have plots, you have text logs, you have maps, you have 3D, you have cameras. And so you need a tool that is inherently a sort of multimodal visualizer, and that's what Foxglove does.
Hell yeah. Yeah, so it makes it so you can understand the state of the robot, so you can understand what it's doing, so you can develop things, so you can understand what might have gone wrong, or see if there's any errors or anything. Lots of use cases.
Right. I mean, if I, you could say that it helps you see what the robot is, how the robot sense, think, and acts.
Yeah. Yeah, very much.
It's like, what is the robot seeing? What is the robot thinking? How do we understand, what is the robot thinking, which is usually what is the robot's kind of mental model of the world, and what are the actions that it is planning on taking.
Very cool.
Yeah.
Okay, so thinking about visualizations, you've mentioned several, but what are kind of like the big classes of visualizations? I'm thinking like you have your plots, you have your 3D one where you have the point clouds and maybe your robot model, something like RViz.
Right.
And maybe then you just have logs that say messages that you want to introspect or something.
Yeah.
Or how do you think of the big classes of things you might visualize?
Yeah. I mean, 3D and images are definitely sort of like one of the larger buckets. All of these things are critical, right? But I would say like 3D and images. So we have a panel for visualizing 3D data. We have a panel for visualizing sort of 2D images. They're actually the same panel under the hood. This is kind of a fun fact. So the 3D the 3D scene can render anything from a 3D point cloud, a 3D bounding boxes of objects, like you said, a 3D robot model, and the robot's pose, so like where it's holding its arms or joints, things like this. But also in the 3D panel, you can render a 2D image into that scene, right? So if you've got a camera mounted on the robot, you can project that camera image into 3D space to sort of see what it is seeing from that perspective. Sort of conversely, in the image panel, you can start with a layer of what is an image that we're seeing. So this is kind of just like 2D sort of pixel coordinate space. But you can project into that image anything from your 3D scene as well. So you can project over it point clouds, as long as you've got transforms, right? As long as we understand the frame of reference of the camera and the relationship between your camera and your LiDAR or things like this. But we can project over the camera point clouds. We can project over the camera bounding boxes. So you can actually see anything from the 3D scene in the 2D scene. You can see anything from the 2D scene in the 3D scene. Even though the UI for them is slightly different, they're actually like the same piece of code under the hood. So that's one kind of really big bucket, I would say. And then the other sort of main or like, big one that's just like heavy use is the plots. So plots are just, very important, obviously, for time series data. Lots of different sort of types of things that people are trying to look at there. But, this can be things like encoders, motors, joints. There's any number of any sort of numeric, any time series data that you've got, you can plot there. Or not time series, you want to plot things like kind of planned velocity in the future, or you want to plot sort of movement even in 2D space. All sorts of things that you can kind of do with plots. And then, other ones that get, but I mean, we have about 20 different types of visualizations that you can do in Foxglove, and an extension API that you can create your own visualization panels. But the raw message one, I think you called out. So just being able to inspect a specific, again, in the ROS world, you can do this by opening yet another terminal window and doing ROS topic echo. Look at like an average ROS developer workspace. There's always like 5 terminal windows and like
tons of
an others and a RQT, and there's just like 18 windows kind of rearranged. We want to,
and they all have their place too.
Right.
Like which one.
Exactly. We want to eliminate this. So. So we have what we call the raw message panel. That's basically like a ROS topic echo. It just lets you see, kind of inspect individual images and pause them. We have like a GPS map, an outdoor map that gives you sort of that's a separate one that's quite helpful if you're looking at
outdoor.
For outdoor types of robots, and you just want to display that on the map. And sometimes there might not be a coordinate mapping from the GPS data to your 3D data, so you can't necessarily just like drop in a street map or like an open street map type thing into your 3D panel, but you do want to see sort of where the robot is in space. And a bunch of other things like that. Diagnostics, a lot of these kind of things, text logs.
Hell yeah. Do you, is there any, does Foxglove visualization, does it fully replace RViz and RQT, or are there any missing?
RViz? Great question. I would say it's probably impossible to fully replace RViz for 100% of people's workflows, in that some people, I guess, like a couple of buckets of things I'll call out. One is people that have created custom RViz plugins. We don't have any way to kind of like
because it's Qt under everything, and you guys are web.
Like a C++ Qt code base, and we've got a web stack. We do have extension APIs, extension concept. You can publish extensions either publicly or internally to your sort of Foxglove organization. But you're not going to be bringing in...
And with no custom plugins on RViz. Is it a fair parity, or are there...
I would say if you're running no plugins in others, it's pretty good. The other one besides custom plugins I would pull up is like the Move It, and I think Nav2 have some plugins.
All that integration.
So we have some of those features, but there's definitely a handful of things that I would say we're not at parity with Others plus like the Movid or the Nav plugins.
Yeah, because they've just been developed for RViz or RQT.
Right, exactly.
That makes sense. Yeah,
Yeah.
I mean, those projects are huge, and so that would be a lot
Yeah.
of work to
And I
port.
mean, things that we would definitely like to, I mean, had plenty of chats with those teams, and the things that we would
Yep.
like to support in the future, and feature requests come up reasonably frequently. But like you say, it's just there's a lot of surface area and visualization.
Yep. Very much.
Yeah.
Yeah. Because it kind of turns into like a browser or something. I mean, it is a browser, but it's like the amount of visualization and display, and eventually maybe you want a UI and
Right.
all sorts of things. It becomes like a sandbox for making other things, is what
Yeah.
it seems to me.
Yeah. It is very open ended, and our goal is not to solve 100% of anyone's problems, right? It's like we want to solve 90% of the problems, but every company is different. There's different types of visualizations people want to do. You need to be extensible and let people, get the last 10% of the way themselves. But, on the flip side, not have to start from zero. There's a lot of companies,
Definitely.
especially outside of the ROS ecosystem, a lot of companies that are using a completely in-house visualizer that they have kind of built over the years, right? And again, this is something that, maybe that's taking up like half an engineer's time or something within the company, or depends on the company size. Maybe it's someone contributing every, once a week, and maybe it's like a full-time team of a couple of people working on it. But it's a significant investment in 90% of that being undifferentiated, right? 90% of that being the exact same shit that like every robotics company wants to visualize.
Yep, for sure. And also, I'm sure that their in-house one would not be as good as something that is like that's the only thing you got. I mean, you guys have several parts to this project, but it's your core focus.
We got
not
the
that
whole
and
team
a robotics
focused on
company.
it. Yeah,
Yep.
exactly. Like leverage a team of, we got 10 engineers right now, I think, kind of focusing on leverage a whole team that's focused on
For
that
sure.
project.
And I mean, you guys have been working on it for years, and it came out of Cruise,
right.
which I don't think we said explicitly, but
Yeah,
a lot of
and
this.
I mean, a couple of our engineers have been working on this project for 7-8 years now. It's the visualizer did actually start at Cruise, and some of our very small portion of our code traces its way back to that, because we created this visualizer at Cruise. We partially open sourced it at Cruise. It got a little bit of traction, but it was also like too tightly coupled to a bunch of cruise assumptions and self-driving assumptions, and was not as useful for other types of robots, other types of like manipulators or mobile manipulators or AMRs and things. It was like, had a lot of built-in assumptions around you're probably going to be outdoor, you're probably not going to be able to move the camera in certain ways. Your robot, a self-driving car doesn't have any sort of like arms or really like joint states or anything like this. So it was, we partially open sourced it at Cruise, and it did get some adoption. But with Foxglove, it was like, hey, all right, let's, take that as a foundation, move it on. I think now we look at sort of, it's like 15% or something of our code dates back to the Cruise days. It's a pretty small.
Yeah, and it's vanishing over time, I would
small
imagine.
And decreasing fraction, but it is kind of that lineage of the project that we've been working on, and some of our teams have been working on for a long time now.
Hell yeah. Now, tell me about the plugins and extension API.
Yeah. So we have a bunch of different ways that you can customize the visualizations. Like I say, there's a lot of different things people want to do with visualizations. So at a first kind of premise, and also in addition to that, one of our kind of founding beliefs is that robotics tooling and infrastructure should be framework agnostic. So quite early on, we started with ROS support, but quite early on, we tried to, as much as possible, decouple ourselves from ROS while still supporting ROS really well, and make it in a way that anything that you can do in Foxglove, nothing in Foxglove requires ROS. Anything can be done sort of just in a general purpose way. So we think about extensibility. The first thing doesn't even require an extension. It's just how do you render sort of arbitrary things, right? So we have a bunch of primitives that you can render. You can publish messages either directly from your robot or with what we call a user script, which is a little script running in line in the browser that you write that does transformations. But you can take your robot data and you can turn that into things like we have 3D primitives, like a cube primitive or a line primitive or a point primitive or the model primitive if you want to render a mesh or something like that.
Oh, cool.
So we kind of have these building blocks of like, you want a stop sign in your 3D panel. Okay, well, just bring a mesh, bring like an STL file or something like that, and you can publish that, wrap it up inside a model primitive message, and publish that to Foxglove. So you have kind of, first of all, these building blocks of like, how do I visualize things, as well as more common sort of higher level abstractions like a point cloud, for example. Great, we can just take a point cloud message and visualize that. You don't have to like write out 30,000 individual point messages or anything crazy like that. And then so you have all of these kind of like drawing primitives, and that's kind of the first place that you would start. And then like I said, you kind of get into extensions. We have a thing called user scripts that I mentioned before, where you can take basically subscribe to sort of topic data coming from your robot that might be a custom message that you've written. Let's say you've got a custom message that's like tracked objects or something, right? You want to render that. So you can write a user script that just says read the tracked object and output like an array of like cubes or something like this, cube primitives. So that's just like a really quick way that you can turn sort of arbitrary data into something visual.
Yep.
And then we have extension versions of that. So the user script is kind of like a lightweight, just like happening fully in the browser. You're editing it. There's like a full-on text editor just kind of sitting there ready to go.
That's
An
so
extension
nice.
is
That's so convenient.
Yeah,
Love that.
it makes it. It's just a lot easier to play around with things. Basically, you don't have
And
to
do something very quick. And if you have a very tiny transform that you want to apply to some data so you can display it, that's very, very nice.
Right.
Okay.
Right. Exactly. Yeah. So,
But that's for only lightweight things, because I would assume like I like my code editor better than this, probably.
Right, exactly.
So then if you have larger projects, now you switch.
Yeah. So that's when you would leap to like a full-on what we call extension. With extensions, there's a handful of different extension types. You can do those kind of transforms. So, for example, we have, I think it's called a message converter extension, where you can say, well, anytime we see a topic of type foo, here is a transform, a known transform that would apply that and turn it into like a Foxglove schema, something that we know how to visualize. So maybe you've mucked around with your user script, and you want to go from your tracked objects to like something visual. You're like, okay, well, that's nice. Audrow's figured this out. How do we, but I've got a team of like 50 engineers who all want to do the same thing. You can bring that into your code editor, bundle it up as an extension, deploy it to your company as anytime really cool. This topic matches this like particular internal data type, this is how you would turn it into something that Foxglove knows how to visualize.
So with that, anytime the topic matches, do you do you code it in the extension that I'm looking for a topic named foobar joints or whatever?
Yeah.
Or
with
do
that
you,
one,
is that
with
exposed?
that one, with that one in the extension, with that example in the extension, you match on a type, like a data type, like a schema. So you would say
cool.
like, Audrow messages / tracked objects or something. That's your kind of custom data type that you've created. So you would just match on that. It doesn't necessarily need to be the topic name. It's just any message that matches this type. And then how and then this is something, again, you would write this in your code editor.
Topic based. Yeah.
We have both. The user scripts are topic based, and the extension is kind of a the extension ones work on a type base, but
cool.
So you have kind of both options.
Yeah. Okay. I was just thinking how to make it not as a rigid if it was topic
you don't want it to be
based.
brittle, right?
And maybe I'm coming with like ROS 2 ideas, so maybe the language is slightly different.
Yeah, but the type thing, I mean, the way we think about the type thing is it's really just like teaching Foxglove how to visualize your custom message, and it doesn't matter what topic it's coming on. It's just like anytime you see, because we know how to visualize a ROS point cloud, we know how to visualize, or we know how to visualize like a ROS marker message or something. We don't know how to visualize like an Audrow tracked object or whatever, right? It's like, so we create. You can teach us how to visualize that by creating one of these little like transformer extensions, converter extensions, and then you can deploy that, like I say, either publicly or just within your team. Yeah,
that's really cool.
Yeah, so that's one. And then there's 3 or 4 different extension types, but the other kind of key one that people make a lot of use out is you can actually create an entirely custom panel, right? So each panel in Foxglove is just its own separate little HTML JavaScript app. And so the simplest possible panel you could create would just be
Hello world.
Right, exactly. Hello world, or just a button or something, right? You can. In fact, the button example is quite cool because you can use the API. You can create a little just HTML page with a button on it. Subscribe to anytime the button clicks. You could actually publish a message back to the robot, for example. And so this is a cool way. I mean, we have a built-in kind of button panel, but it's like people want a lot of different things out of buttons, so you may as well just make your own little form. Create whatever, you can display whatever you want, you can handle button clicks whatever you want, and you can publish messages back to the robot as well.
Now, given, like I've worked with, I tried to make some Foxglove extensions in the past.
Oh yeah, cool.
But so with this, it's all, so you're running Electron and your UI it's a TypeScript with React, right? So if you want to add these buttons and things, you're using TypeScript and React.
We use TypeScript and React. There's no requirement on that for an extension.
If you wanted to do your custom panel one, is there a requirement on it?
No,
for the other ones?
We do, I think, sort of because we use TypeScript, I think we a lot of the templates that we generate and stuff will use it, but there's no TypeScript is just compiled to JavaScript under the hood. So you can use plain JavaScript if you want. But as far as React, there's actually no dependency on React within the panels themselves. So each panel,
you could just put HTML.
If you want to add React, you do. That's fine. But yeah, you can just stick like a very basic hello world, HTML like you would have written in the 90s kind of thing there if you want.
So it's very flexible. You basically say load this web page from here or something like this, and it just does it. Okay, so you get all that flexibility in.
Yeah, and
that's
then,
cool.
And then sort of up to you if you want to. I mean, I've seen some people do crazy things with extensions. You can sort of use that to load some WebAssembly or do anything you want really.
Yeah. That's really cool.
Yeah.
Yeah, WebAssembly is so exciting.
Yeah.
For all the things you can do.
Yeah. Some it's still there's very interesting things being done with WebAssembly. It's still sort of an earlier stage technology, and there's a lot of there are kind of rough edges around how you kind of move back and forth between WebAssembly things and browser things, but it's coming along really nicely. And we use WebAssembly internally for some performance critical things too, like when you get into for example like decoding bags and you're doing like decompression, LC4 decompression, LC standard, things like this. We're actually using like what you are getting in Foxglove is C++ code that's being compiled to WebAssembly to do a lot of that, like decompression and things.
Yeah, so it's nice and fast. That's great.
Yeah.
What a cool thing.
Yeah.
Yeah. I'm excited about WASM, WebAssembly.
Yeah.
Just in general. So can you, this might be kind of so we've already mentioned you can make UI, which is cool. So you can make a button, it can publish a topic, and then that can be used to like control your robot or do something, or maybe even pop up different parts of the UI or do things within the Foxglove program, I would imagine. Would you ever imagine this being like a front end for a simulation? Like we have Gazebo's server, and then we have GZ, I don't know, client or whatever it is, the renderer.
Yeah.
Would you ever imagine using Foxglove as a way of displaying simulation, or I don't know, connecting it more closely to other simulators?
Yeah. We do see people, like today, people use Foxglove a lot to visualize the output of a simulation. Because typically in a simulation, there is the perspective of the simulator, and it's, sort of, you can think of it as like, okay, here's this third person view of like what the simulator is trying to create. But then that data is being created into sort of false, it's creating sensor data, and that's being fed into your robot stack. You do want to visualize the other end of it, which is like, what does the robot think that it's doing? So that is very common. People like visualizing the output of simulations is very common.
By sort output, you mean the result of what the robot thinks?
Yeah, exactly. Yeah, like the recording. If a robot is driving around in the real world or whatever, moving around in the real world, yeah, exactly what others would see. So if a robot is moving around in the real world, you have a recording of what it saw. If a robot is moving around in simulation, you have a recording of what the robot thinks it saw or what the robot thinks it was doing. So that's kind of like you say, that the sort of the others output of the recording and what kind of came out of the simulation. So that is necessary. I guess like the question then becomes, could you have one UI which is sort of like solving both the simulation need and the robot need? I think it could be done. I think it would be a ton of work. And we don't have any plans to do that. I think it would kind of conceptually make sense that you could create all of the buttons that exist in Gazebo. You could create create a Foxglove plugin, or it could be a first party supported thing, and that could just talk to, like you said, the Gazebo server. But you would have to recreate all of that UI, which number one, so that's like a lot of work that has to be recreated. And then you've got this problem that there are a lot of simulation sort of frameworks and engines in the robotics space, right? And so now you've done all of that work, and now you just support Gazebo, but you don't support like Isaac Sim, you don't support any number of other simulators that people are using.
Yeah, just tons of them.
Yeah, and so you just end up in this kind of
You've overcommitted to one.
We've got enough things to do in the visualization space.
Yeah.
I think if it was done by maybe if that was like a third party, a plugin or something, and that someone was dedicated to maintaining that, it could maybe be done. But it sounds like a lot of work.
It's not directly interesting.
Yeah.
Or you're overcommitting a bunch of resources to something that kind of works anyways for this. And I guess it does require a lot of I don't know about the build story of Gazebo on different platforms, but okay, and then you come down to you've done all that work and now you only support one simulator, and then a lot of them,
other people in the industry are using different things.
But like Gazebo, for example, I mean you can swap out the physics engine, and that could still be a cool thing.
Yeah, it would be interesting. And I mean, I think that statement would make more sense in the ROS world, right? Like within the ROS ecosystem, it might make more sense to have like Arvas and Gazebo as a single UI, because it is part of just one ecosystem and you don't need to. But for us, with our sort of our stance on being framework agnostic and things, it's like I don't want to have sort of a situation where it's like, well, we're only really useful if you're using XYZ simulator and not a different
not this one. Okay.
It's so sort of a little bit of a unsolved problem there.
For sure.
Yeah.
So is there anything else to mention about the visualizer or plugins, or is this the full extent to the stack, or are there other things?
I mean, this is largely how we think about it, right? We talked about recording, we talked about getting data off the robot, we talked about indexing data in the cloud, we talked about sort of search and discovery of that data, we talked about visualization. Some of the things that when you think like a little bit down the road, things that we would want to do to round out that are around like better indexing of data, better search and query across data.
I imagine
analysis.
I imagine making things easier for like machine learning training kind of thing.
Because
you have your indexing. That to me seems like, especially given like the zeitgeist in robotics, it feels like everything is about all the AI, all the machine learning.
Absolutely.
And so
this is becoming
those workflows.
Yeah, it's becoming a much sort of more important part of robotics development. Historically, I think a lot of robotics machine learning was limited to just the perception side of things and just sort of like basic image detection models like YOLO and some of these things, classification models and things. But now we're seeing people move to like much more end-to-end learning, training based on multimodal data, not just images. And so, like you sort of alluded to, you've got all of this data in your cloud. How does that kind of feed into your pipeline? And I think one of the more interesting pieces there that we're sort of thinking a lot about right now is this concept of data set curation. So you've got all these examples.
Set curation? Is that what you said?
Data set curation.
Set curate. Oh, so curating it.
Data set. Yeah, curating
so
your data set.
annotating
Sorry,
curating.
Nobody understands my Kiwi accent. It's
I don't know, but okay.
The data. Yeah, so you've got data set, right? You want to build a data set, a training data set. and you've got all of these kind of examples. You've collected all these examples of like robots kind of doing good things and completing tasks successfully, and you've got a bunch of examples of robots doing bad things and dropping objects or backing into objects or whatever they're doing. You want to sort of add a lot of metadata to these. You want to build up a data set. You want to like tag and organize them. You want to know, do I have a good distribution of data across like different tasks that I'm trying to complete? And all of these types of things, right? So we need that metadata, and then we also need sort of full versioning history of all of that metadata, because we want to know, if I go train a model, I need sort of lineage back to like, well, what was the sort of data set I used to train that model? What were all of the episodes, all of these kind of recordings that we used to train that model?
Yeah.
So
you want all of that information so you can understand things.
So that becomes interesting.
Reproducibility.
And then people, there's usually, you're not taking a robot recording and directly feeding that into just like PyTorch or something, right? There's usually some transformation that's happening there. So again, these are things that are on our mind as we think about this life cycle of data from logging and recording to cloud. Absolutely, things that we would like to help out with in the future. But it's also we do try to make sure that we do our core things well before we get too distracted with everything else. Yeah.
Yeah, it seems like there's been the joke that I've seen on X quite a bit, where it's like everyone's digging for gold, so all the AI stuff. Yeah. And so NVIDIA is selling shovels for this kind of thing.
They're doing well, yeah.
But so I feel like you guys are well positioned to help with data annotation, curation, these kinds of things, because you have this top-notch visualizer for seeing data, and then you could make it so that it's very easy to annotate and export to your models, this kind of thing.
Yeah, and where possible, there are lots of existing, you think about like image annotation or whatever, right? Like there are lots of existing tools out there for this. Like the
multimodal robotics specific,
multimodal, there are definitely fewer tools, but there are ones out there. I think to the extent possible, we would, we can't build everything, right? We can't be the tool for like robotics development or something. To the extent,
pragmatically focus for sure.
My belief is that there needs to be way more companies building robotics developer tools, right? And like, we would like to say, hey, look, we've got the core strengths that we're good at here. I'd love to have more integrations with other tools out there. And like we talked about some of these things, like sort of the more of the operational workflows and like fleet management and things, right? It's like. It doesn't make sense for us to build everything at once. I'd rather be good at some really core, good at some core features.
Yep. Yeah, I think that makes a lot of sense.
Yeah. Labeling as a whole kind of can of worms. I think it's. I
think it's true. A million types of data, all the permutations.
Yeah. The high level, I think a much kind of more sensible thing to start with is just more of like metadata labeling. So it's like you're going through and you're wanting to like rate particular episodes, and which ones are good or bad, or which ones are matching different criteria, or some companies are even looking to do like English captioning, right? It's just like, this is a person like picking up an apple or something, because they're feeding this into models now, right? They're feeding in just like the natural. They take an existing like vision language model off the shelf, feed in a bunch of robot data, like the text captions plus the robot sort of state and pose and things like this, plus the sensor data, feed that in, and they can build sort of what's called a world model that has a concept of like tying these movements and things back to action, which is really cool.
Okay.
Yeah,
that is really cool. Are there like we don't have that much time, but you'd love to see way more tools in robotics. So you mentioned some, but could you kind of like rattle off a few that you think are good opportunities for people?
Good, yeah. If you're going to start a robot startup today, I mean, I would say if you're thinking this, if you're thinking about a company starting a robotics tooling startup, just go work at any robotics company for like 2 years, and you will come up with, you'll have suddenly 50 ideas for startups for robot tools that need to exist. But like, I don't know, areas that seem underserved, deployment to robots, for example. There's a huge industry of CI/CD for servers, right? There's almost no one. There was one company doing this. I don't know if they're still around. But just like, how do you deploy and update robots in the field? You've got to think about sort of deploying them without breaking them. That's a huge sort of thing that's interesting. Configuration management for robots out in the field. How are you like, keeping track of the fact that you've got like potentially different robot models, different SKUs, different sort of what service history has happened. Everything that every company ends up building internally should probably, I mean, if it applies to multiple robotics companies, should probably exist off the shelf. So there's a lot of the stuff around the operations of just like deployment, updates, configuration management. Other like simulation is another one that I think is like quite underserved. It's like, there are some of these open source things like Gazebo, but I think there's a lot missing in there, and like frameworks to let you run simulations at scale, the tools to let you manage and create simulation scenarios. How do you manage like testing a new release? Well, you need like a whole catalog of different scenarios that you're ready to go simulate, and you need to be able to run different aspects of that. You need to be able to score the output of simulations and say like, is this better or worse? It's not just like, hey, run this test and fail if we crashed or something, right? It's like, through the metrics, how well are we doing it? Are we better or worse at completing all of these tasks in aggregate? There's just endless. I mean, I could go on for hours about all of these things, and like I say, you work at any robotics company, look around pretty quickly, you'll see what's being built in-house that really is not unique to that company.
Yeah, I think that's a very good way to think about it. Just whatever's being built in-house is probably something that you could hire someone to do something better and then just use. So the company doesn't have to maintain it and do undifferentiating work.
I mean, and the end state of this is that even a lot of the autonomy that's being built is not, should not like be, people in a lot of robotics companies today, I think, see data as a key sort of value driver for them, and they see like their autonomy stack as being like really core to their mission, right? It's like, okay, we're solving autonomy for X, but the reality is that when you're creating a business, the thing that you are creating, the value for your company is like the value that you're creating for a customer is the problem that you're solving for them, and not how you implemented a solution to that problem. And a lot of these autonomy problems are like, picking and placing, or they're navigating around warehouses. How many different
or outdoor
or outdoor. A lot of these kind of just like, and that's why things like nav exist, right? But it's like navigating around autonomously is not a core kind of value driver for your company. What is valuable is the problem that you're solving for your customers, and quite often is the distribution of how you're getting to the customers and how you're wrapping it up with service and how and support. And you think about sort of the vertical SaaS industry today. There's millions of startups building like
very specific
solutions, and tons of them making tons of money,
doing great.
Right. They go out there, they talk to customers, they listen to a business problem, and then they glue 5 things together. Random open source, like there's there's a bit of it, but they're not solving a technology problem. They're not taking on technology risk. They're taking on kind of product market fit risk. So they go and they listen to customers. They build a thing as quickly as possible by gluing together as many off-the-shelf components as possible. And then they go and sell it and work on it in the market and bundle it up with support, and they solve a problem for people, and they get paid very well for doing that. The robotics industry today is kind of the complete opposite of that, where you have a lot of companies that are solving blindingly obvious problems. It's like, wow, if you could get a robot to do that would be fantastic. This is like, that'd be amazing. But they're taking on this massive technology risk of like, well, now I got to get the robot to do that. It's kind of completely backwards. And I think when robotics has kind of succeeded, we will see that flip. We'll see that invert, right? Where a robotics startup will mostly be talking to customers, listening to their problem, figuring out how you're going to connect with those customers, how you're going to market to them, how you're going to sell to them, how you're going to support them. And the technology will, to the extent possible, be taking together a lot of off-the-shelf hardware, a lot of the off-the-shelf software, a lot of off-the-shelf infrastructure, a lot of off-the-shelf autonomy components, probably just grabbing some off-the-shelf like open source foundation models, fine-tuning them a little bit, and like solving a customer problem, solving a customer need, solving a business problem, not all of this like technology risk that people are taking on today.
Definitely, 100%. This is part of the reason to me companies like, do you know Polymath Robotics?
Yeah, exactly. Similar kind of thing, right? It's like, you don't need to be building the autonomy stack.
I think they are early on this trend, and I think we're going to see a lot more of that is my guess, where they're solving navigation, for those who don't know, and outdoor navigation, like driving slow in fields or something like this,
right.
and you just call it from APIs.
Right.
Like
Yeah.
that seems like the way to go for a lot of things.
Yeah, exactly.
Because you don't
Yeah,
have
I
to
think,
do that risk, the
yeah,
technology
and we
risk.
get to a point where those, similar companies, maybe it's Polymath, maybe it's others, but like, similar things just exist across the board, right? For
Every
warehouse robots,
domain.
for agriculture
Yep.
robots, for,
For
drones,
UAVs.
you're right.
Yep. Yeah, exactly.
Yeah.
We're on the same
Yeah.
page.
Yeah. So I think, we will definitely see a lot more of that.
Hell yeah. So talk to me about the 2.0 Foxglove,
Yeah.
and then the decision to make it closed source.
Yeah.
I know some things are open source, but
Yeah.
some things are now closed source. So tell me
Yeah.
about all that.
Yeah. Yeah, absolutely. So I think like there were two kind of arcs that happened. Like I said, Foxglove, we're about 3.5 years old now. There are a couple of sort of things that we noticed over the first few years of Foxglove. The first one was that we sort of started out. We started out with the Foxglove visualizer, and then we sort of added on this idea of like we're going to build a data platform kind of thing, and we thought of them as very separate components, and they are separate components to an extent. Like I said, the visualization is useful not just with cloud data, you can also use it with local data or live connections, and the data is sort of independently useful. But we took that too far and we built them as like literally completely separate code bases with separate repos and separate UIs. And then we start sort of tripping over ourselves with like, how sign-on works across them and sign-out works across them, and how if you're viewing some, you're exploring some data to find the right log file and then you open it in the visualizer, you've lost all reference to how you got here and what the metadata associated with this recording was. And, if you want to just be clicking through a list of like kind of a list of a bunch of different examples of events or things like that, you want to just be able to quickly click through them. You don't want a whole separate tab that's just the visualizer and a whole separate tab that's just the browsing interface. So we sort of came to this realization that it was even though they are kind of separate product features, it was a mistake to like build them as completely separate apps and completely separate UIs. And so we came to this decision that we needed to merge these together, and that was kind of the Foxglove 2.0 was like, hey, we're going from these completely separate, literally separate code bases, separate tools, to one kind of observability platform. Like I said, it's modular. It's got a bunch of features. You don't have to use all of them, but it's one UI. You sign into it. You just it's one kind of app, and you can do things like with 1.0, you could not do the data browsing in the desktop app. There were kind of weird inconsistencies where you could on the web you could browse the data and visualize it. The desktop app, you could only visualize it, you couldn't browse it. Now all of that's gone. It's one app. You can use it on web, desktop. All the features are available on both platforms. And so that was, kind of the first key part of 2.0. And then the second piece of it was, like you said, around open source. Now, our initial sort of decision was, our initial kind of plan for the Foxglove company was that we would build this open source visualizer, and then we would have a paid service that is like the data management service,
the cloud and everything.
The kind of the
so
cloud.
You can get it with Teams, so Teams can use it well, kind of thing.
Yeah, with Teams, and the idea was that there would be some sort of team visualization features, but there would also be most of the team features would revolve around data management and, like I said, uploading data, organizing data in the cloud and things like that.
Yeah, that's what I understood from our last interview. Okay.
Right, which was, that was kind of the plan that we set out with. And, we tried really hard to make that work. I think the challenges that we ran into is that visualization itself is just a really a bottomless, very difficult problem of a bottomless pit of feature requests. And so most of our effort, even today, sort of like 80% of our effort goes into the visualization, right? So we ended up with a sort of challenge where we're trying to sell a product, but some people were not interested in some people don't care about the particular sort of like the cloud data features, right? They're like, well, we figured out the cloud data piece ourselves. We really just want the visualization piece. Again, we try to build a modular platform, so that's nice. You just want the visualization piece. But that's a thing that we don't, we can't make money on. So it's just an endless stream of incoming feature requests and work. And work that we do for people, but no way to charge for that. The only thing that we're charging for is the sort of the cloud data management, which some customers, didn't want. So there was a bit of a mismatch between what we were spending most of our time on building, and the thing that we were charging for. And, that causes a problem as a company because we want to make the visualization great. But it's just, it's not possible to do that if you're spending most of your time building the free thing. I guess another, I would say, and coming from, I'm a developer by trade, and, I spent a lot of time using a lot of open source projects, and we cared a lot about open source. I think the analogy, and we still care a lot about open source, we support MCAP. I think, MCAP is, MCAP is an example of a great sort of open source project as a company, right? It's something that you put out there. It makes a lot of sense to be an open standard. It's a library. It's not like an app. So it doesn't have buttons and UI and things like that. It's a library. People are much more likely to contribute to it. We get a lot of community contributions with MCAP. By contrast, we get very, almost around to zero community contributions for like a web-based JavaScript visualizer tool, right? And then also with MCAP, it doesn't take a lot of our focus, right? Maybe it's like a 10% focus for us, but not an 80% focus for us. So we sort of maintain the project and keep updates, and there's ongoing development on it, but it's not kind of the primary focus of us as a company. And I think you need to think really hard. If anyone is sort of founding an open source company, you need to really think about like how much the open source project is going to take of your like overall development resources, and make sure that you have the capacity to also invest in whatever the thing you're selling with. In some senses, like and this is sort of a little bit of a tangent, but when people ask me about creating an open source company, I think one of the biggest challenges with open source is that you actually have two product market fit problems, because you still have, even though usually every open source company has like an open source thing, and then they have like a paid thing that sort of supplements it, right? And even though the open source thing is free, there's still a product market fit problem. You still have to make sure you're creating a thing people want. You still have to spend a lot of time on kind of marketing it and posting on social media or word of mouth or whatever. You still have to like spread growth of that thing. And then that entire thing repeats itself with the paid product that you create, right? You have to create a thing people want. It has to make sense. It has to be enough of a value add on top of the free thing, and the same thing, you have to figure out how you're going to market it, how you're going to sell it. And so you've created kind of twice as much work for yourselves. But yeah, we really found, that we were not able to invest the time and effort we needed in the visualization thing. We weren't really getting the sort of community contributions that we would get with something like MCAP. And frankly, like, most of the people we kind of talked about to this were like, most customers even, and potential customers were like, well, why aren't you just charging us for the visualizer? Like, that's the thing we want. Why aren't you just charging us for it? And so, but we still have these principles, right, of that I think were well placed when we started, which is that we want it to be easy for hobbyists to use. We want it to be easy for academics to use. We realized, again, since most of the people that were using Foxglove we're not taking advantage of the fact, like, they liked the fact that there was a free version. They can download it, they can get started, especially, like I said, hobbyists, academics, or, the first few people at a company where they're just trying it out. They like the fact that it's easy to use. They weren't creating a custom fork of it or a custom build or deploying a custom build or anything like that, right? It was mostly just the fact that there is a free version that's easy to get started with. And I think that was well placed. So even though, we came out with this announcement about, around 2.0, so I think it was about 3 months ago, was saying, hey, we're not continuing any further development on the open source version of 1.x. We did have features that were always for example, like, you go and download the Foxglove application, that always included some closed source components. So that was always our distribution, included the open source and some of our other components. We just said, hey, the open source release, we're not continuing to develop that. The 1.x code is still there if you need it, but we're focusing on sort of going forward, we're focusing on just keeping all of this within the closed source build that we have been releasing. Honestly, I mean, it got very little. As far as like sort of announcements go, it got pretty little attention, and I think, like I said, it didn't really change much for most people. Like most people were already using,
Totally.
they downloaded our desktop app. That was already a closed source build, because building things like a Mac OS app with signatures and all of these things is like, it's not, particularly easy to do anyway. That already wasn't the open source build they were using. The update to 2.0, it looks pretty similar. We've added some new features and things, and we've spent a lot of time on performance lately, but there was no disruption to workflows. Especially for the broader community, for individuals using it, for academics using it, for hobbyists using it. There were some companies that were using it in a company setting, but again, they were already we already had some of these things like prompts. If if you're using it with more than X number of people, you're already seeing like, hey, over 3 people, you've got to pay. So there wasn't really any significant kind of change in the experience there for people. The only people that it affected was sort of a small number of people that were kind of walking it. On the other hand, I think another sort of piece of advice that I give to people kind of building a similar sort of like open source based company now, especially having reflected on a few years of this at Foxglove, is that you need to sort of have in your mind a mental model of like what percentage of people that use your free thing are going to upgrade to your paid thing. It's not even really to do with like open source, right? But open source makes this problem worse.
Yeah, it's just a conversion rate for keeping your company existing.
And typically that is going to be pretty low. So you think about, there's a lot of open source databases out there, for example, right? So there's something like InfluxDB. This is like a time series database, and then you can use like the hosted version, or there's MongoDB, or there's Elasticsearch. A lot of these are open source, or sometimes they're sort of slightly more creative licenses more recently, Redis and things. But they have open source database, and then like they have a hosted version. But it's a very like extremely generally applicable thing. Like Elasticsearch is a full text search database, or Redis, you can use it for just about anything. If a fraction of 1% of people that use that, move on to the paid service, that's still like a large, right? It's plenty. It's still like an enormous kind of market that you're talking about. Robotics, unfortunately, is not like that, and basically we can't afford for only like 1% of of big companies that have raised a lot of money, or in some cases like big multinational like car companies and things like that, that have enormous global presence, enormous revenue. Every one of those that sort of decided to just use the open source version because that was sufficient for them becomes like lost revenue opportunity, right? And that is, again, if you're operating in an enormous market with like tens and thousands of potential, or hundreds of thousands of potential customers and companies, that's fine. If you're working in something a bit more niche, like the robotics industry, you can't afford to have just like such a tiny conversion ratio.
Yeah, that makes good sense to me. Yeah, because we're a much smaller community than like the web developers, say, like
or databases, or
databases, which are everything.
It's just like every company and that needs a database.
For sure.
Yeah. So, but it's been good. Honestly, the response to that was super positive. Everyone. I mean, good. I would say maybe there was like 1 or 2 messages that popped up on like Ross Discourse or things that were sort of a bit upset about it, but on the whole, pretty much everyone was like, yeah, that makes sense. It's totally fine. And
good.
And, the main concerns that came up, maybe we miscommunicated a couple of things, but some people came up and thought we were getting rid of the desktop app, which sort of caught me off guard because I didn't expect.
Not what you're doing at all.
Yeah. Right. In fact, we're adding more features to the desktop app. But that popped up, with a few people, and we had to sort of correct that misconception. And the other one was just, like I said, is making sure there's still a free version. So it's not really any different if you go to our website and hit the download button today. It's the same experience that you were getting 3 months ago.
For sure.
We've still got the extension APIs. That was another one. So people were kind of concerned that the extension APIs were going away. But these things are,
they're still there.
It's largely the same experience. It's just that we have a more clear licensing now, where if you're using it for up to 3 people in a company or in a team, that's free, and then over that you got to start paying us. Yep,
that makes sense. I mean, you guys need to eat too.
We do
this kind of thing, and keep
like
making the good software.
we want to create this really great software. We want to keep investing in it,
but you have to exist in order to do that. And so I don't know. Okay, that makes good sense. I think like to me, even just the first point of it's easier for us to maintain is huge because you
Yeah,
guys need
yeah,
your time.
right.
And I mean, so I've been involved with the Ross project for a long time, and there's like, you need the staffing to do that, or
Yeah,
you can sour
yeah,
relationships too.
yeah,
Like
yeah,
someone puts out a feature request or something, and if you don't get to it after a while, there's a little bit of bad blood that's created there for this kind of thing. So I
yeah,
mean, if it's
yeah,
like endless visualization features,
right.
I can understand how kind of turning that off, because the expectation is if it's open source that you're going to be triaging everything and
Right, people come up with the
yep.
the bug reports and things, and
So
yeah, and we do want to get to that. And now, honestly,
yep.
I mean, like you said, the moving fast thing is important too, right? Like now,
Yep.
internally, we just have a single, like I said, we merged
Yeah.
all of the code between the sort of data and the
And a
visualization.
better
So moving
product
to
experience too.
right, better product experience. We're not juggling like open source repo that we're then trying to incorporate into another product and things. It's just like, well, we're building this one app.
Yep.
People sign up for it, they use it, and
Yep.
it's a pretty concept people are pretty familiar with.
For sure. Yeah. I
Yeah.
guess like I guess the moving from open to closed, it like saddens me a little bit, but I understand for very pragmatic
Right.
reasons. And I think it
Yeah.
was probably a very good decision, and I bet it was a very hard decision. So I
Yeah.
respect
I think
making the decision, and I think it'll be better for you guys
yeah.
long
I
run.
was probably but with every decision as a company, you always think, wow, we could have made that decision a year ago or 2 years ago.
Yep.
It's sort of, in hindsight, I think, like I said, coming from a engineering background and using a lot of open source software, and
Yep.
I was probably the most saddened out of everyone, right? People kind of pop up and they're
Yep.
like, oh, we're sad that you're moving. I'm like, look, I am too, but
Yeah.
but we
Yeah.
had to do it.
I think so.
It made sense, and I think when you talk through it like that, you say, look, these are kind of the constraints that we're working with. Yeah.
Totally. Yeah, you guys have to stick around. And if you devote
Right,
your
right.
resources to something that's not helping you stick around, like if you guys went out of business, that would be a much bigger
Right,
loss
exactly.
for the
Right.
community.
It's not a
than
choice
this.
between us continuing to develop for free
No.
and paid, right? It's like, look, we
Yep, yep.
want to exist as a company.
Yeah, for
and
sure.
we're not,
And it's such an exciting time. So like you definitely want to exist in this super
right.
exciting time.
Yeah.
But
Good time to be in robotics.
so
Yeah.
we're coming to the end of the time. One thing I want to make sure we talk about. Tell me about the Actuate conference and
Absolutely. Yeah.
why
This is,
and what you're showing and everything else.
Yeah, so Actuate is a one-day event that we're putting on in San Francisco. It's going to be on September 18th. Got a really nice space that venue that we've booked in the Dog Patch in San Francisco. And this is an event, a conference for robotics developers. Anyone, robotics is a very sort of cross-functional domain. There's a lot of people working on a lot of different things. But we want to bring together engineers, across people working on perception, planning, AI, simulation, frameworks, hardware even. We want to bring together a lot of these different disciplines. It's a one-day event. We've got some really great speakers lined up, and we've got some really great attendees lined up. The goal of this is how can we bring together just a lot of the community in the Bay Area where we get to talk to, as I would say, in the position that we are in as Foxglove, I get to talk to a lot of different companies and hear a lot about how they're building their robots. None of our customers talk to each other. There's a real gap in the robotics industry of sort of like deep technical content on how people are building robots in production. There's a lot of, content out there from the academic perspective, right? There's a lot of papers. There's a lot of robotics conferences you can go to and listen to. A lot of sort of the academic perspective. Not so much in industry. I would say the stuff that exists in sort of the industry today, in terms of like talks and conferences and things. ROSCON is a similar level of, has the technical depth, but it's centered around ROS. So I would say ROS is one framework in the industry, but we see a lot of our customers not using ROS, and we'd like to have a broader perspective there. And then you see a lot of kind of robotics trade shows like Automate and things like that, where you've got the sales team, they've got their robots, they're showing off their robots, but it's not how they built the robot, right? This is just like, look at what the robot can do. So we felt that there's this kind of, there's a real gap for high quality technical content in the robotics industry talks, and not just listening to the talks, but getting together and networking with other people in the industry. And I think, because it's a one-day event, we're expecting it's going to be a mostly Bay Area audience. I do know some folks are flying in for it, but for the first year that we're doing this, we're expecting that we're mostly going to have kind of Bay Area attendees. I think we would look to go, a bit larger next year, probably.
Hell yeah.
Yeah. And then in terms of speakers, we've got a handful of really great speakers lined up. We've got Sergey Levine. He's a professor at Berkeley and co-founder of company Physical Intelligence. We've got Chris Lancet. He's the technical lead of ROS. Steve Masensky. He's the technical lead of the NAV2 project. Kat Scott from Open Robotics. I think you'd be very familiar with her. VJ from Wave. He's the VP of AI at Wave. So we've got a lot of good speakers already, and then I think we have a number of we currently actually have a call for proposals open right now. Number of super interesting proposals we've had come in. Like I say, we want to really find a great balance of content across people working on AI, people working on sort of perception and planning, people working on simulation, just cover the whole sort of spectrum of different things that are needed in robotics, and help kind of encourage some sharing, have some really great speakers, but also have really great attendees and high quality kind of conversations.
Hell yeah. Do you is there much planned for like the evening after the event or everything? Because I find like
exactly.
the unstructured time to just talk with all the attendees, to me, that's my favorite part of the whole conference,
right,
in general.
And I also, there's structured lunchtime. There's a cocktail hour. I think it's sort of from like 4 to 6 or 4 to 7 or something like this. We've got kind of like a happy hour at the end as well. So there will be plenty of kind of unstructured time for chatting. Also, just a single track event is a really fun thing. I think, a lot of these larger conferences, get to a point where there's all these multiple talks and there's rooms and there's a presentation, there's a hall with all of the, vendors and things, and you spend most of the conference kind of wandering around. But I think the beauty of a single track event is that, there'll be nice punchy talks. You come in, hey, we're having this session, just like everyone listen, and then everyone can go out and we'll have like some time to chat and get to know people. So yeah, we absolutely like the networking time's good, but I also think the beauty of a single track event is that you don't have any of these questions of like, oh, which talk should I go to? Or should I just maybe I should be networking instead of listening to the talk? And yeah, it gets a bit,
oh, hell yeah.
Too many decisions.
That sounds like so much fun.
Yeah, it'll be fun. It'll be awesome. So, would love to have you there, Audrow, and we'll make that happen.
Hell yeah. Yeah, I would love to go. If it works out, I think I'll be there.
Nice.
I think you had like some code with my name, which was
absolutely
fun.
Yeah. So for folks listening that have made it this far in the podcast, so a couple of things. One is we currently have early bird. Like I said, the event's on September 18th. It's a single day event, San Francisco. It's from about 9 a.m. or 9:30 to 4. Then there'll be a cocktail after that. We have early bird ticket sales going on right now, so I think the first 150 tickets that we sell are $150 or $149, something like that. So get in quick before those sell out. And then we have an additional, I think on top of that, it'll be additional 20% discount for listeners of the podcast. Just put code Audrow in at checkout, AUDROW. That's the secret code, which will get you an additional 20% off. 20% off the early bird price if you make it in time, or it will be 20% off the full price if you're a little bit slow. So get in quick.
Oh yeah. Awesome. So with that, I think we shall wrap up. Great talking with you, Adrian. So cool to hear about Foxglove and all the great work you guys are doing.
Absolutely.
And I hope to see you at the conference.
As always. Thanks, Audrow.
All right. Bye, everyone. That's it. You made it. What has your experience been with Foxglove? Or if you haven't used it, do you think you'll give it a try? If you like this interview, I'd appreciate a like or a review. It helps other people find the podcast and pleases the algorithms. And if you'd like to make sure you hear about new episodes, make sure to follow or subscribe. Our next episode is a very strong robotics company in the food space. They're doing great work with robotics and machine learning, and they've already done over 5 million food servings in production. That's all for now. See you next time.